Hi, everyone. My name is Derrible. I'm an associate professor in the Department of Civil Materials and Environmental Engineering at the University of Illinois at Chicago. It's a pleasure to be here presenting at this workshop. I wish we could all be together in Vietnam, but we're not. We're online like we've been in the past 2 years. So be it, but I'm really hoping to meet all of you in Vietnam in the next few years. What I want to do today is to talk in line with the workshop to talk about sustainability and resilience, but I really want to frame it within the context of infrastructure and really to bring you a bit more at the conceptual level of sustainability and resilience, especially applied at the systems level. That's what we're going to try to do. So sustainability, resilience, what do they mean? I mean, those terms are vague. I don't think we should necessarily seek to have an official definition or a great definition, but they are vague. And so what I want to do is really talk to them within the context of infrastructure, apply them again, maybe just challenge the way that we understand them. Usually sustainability, we associate that with low energy, low carbon. We'll see that we have to be careful a little bit with that notion. And resilience, a lot of times we'll restrict ourselves to robustness or redundancy so that when a disaster or some event, disruptive event happens, that we have some alternative options so that it doesn't fail. So again, I'm gonna challenge that a little bit, apply it to the systems level within the context of urban infrastructure. And when I say urban infrastructure, I mean, what I'm going to say now should apply to all of them. I like to describe myself as an urban engineer. I'm not focusing on one or unique infrastructure system, but I look at all of them. So I look at water systems, wastewater systems, transport systems, electricity systems, gas systems, solid waste management systems, and also even telecommunication. And I try to look at all of them, their interdependencies, their interrelationships, and within the context of sustainability and resilience. So what does it mean for us? What we'll do is we're going to start with sustainability, then we're going to go to resilience, and then we'll have a small case study at the very end to illustrate some of the points that we're learning in sustainability and resilience. So sustainability, I like that common definition. That's the definition that's probably the most commonly accepted in the world. Some people don't like it. I actually like it a lot. It's sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. That's from the World Commission on Environment and Development, the Brundtland Report. That's how it's better known. That was in 1987. I like it a lot because I think it makes it sort of easy. Sustainability is essentially the ability to sustain an activity forever. If we do something and we can do it forever, then it's sustainable. If there's something that we're doing that's not working and we can't do it forever, then it's not sustainable. Another way to think about it is to give it more of an economics twist to it. And it's to how we have needs and we're trying to meet those needs. We have needs that's a consumption, so we're trying to consume something, and to meet those needs, we need to produce something to be able to supply for that demand, for that consumption. So essentially what we see is we have production and consumption, and what we want is for the production to always be larger than the consumption, always. So it's not only about production minus consumption is greater than zero. For it to be always greater than the consumption, what we can do is instead of looking at the production itself is to look at the rate of production and the rate of consumption. So one of the ways that we can turn this definition of sustainability into an equation is by having this dp over dt minus dc over dt is greater or equal than zero. So again, the rate of production, no matter what happened, the rate of production is always going to be greater than the rate of consumption. We usually don't have this equation. I don't think this equation is necessarily very helpful in practice, but just to think about again the concept of sustainability, I like it a lot and I use it quite a lot. What we can do is to even illustrate it. So here's we have a figure with the x-axis, we have the time, y-axis, we have production and consumption. In the first case here, we see that production curve is going up, the consumption curve is going up as well, but the production is systematically higher than consumption. And so in that case, we're just in a sustainable scenario. A good example of that for some places in the world, not everywhere, is water consumption. I live in Chicago. We have Lake Michigan next to Chicago. Lake Michigan is one of the biggest lakes in the world. We're fine with water. The population could double, could triple, would still have enough water. So we are in a sustainable state when it comes to water consumption, at least in Chicago. Now there are cases where we're sort of in between, where right now the production is higher than the consumption, but the rate of production is lower than the rate of consumption. And so we're in a tolerable state where we're okay, we're meeting all our needs, but something is going to be different in the future. A good example of that is solid waste management. we're generating waste, we're collecting that waste, we're trying to put it in some dumps, in some landfills, and it's could be okay. We have a lot of space, but at some point, that rate of consumption or that rate of generation of waste is going to be so great that we're not going to have enough landfills. So that's why reusing, recycling, repurposing is something that we must all do. That's a good example again for service management of the tolerable scenario. And then we have the unsustainable scenario where the rate of production is just lower than the rate of consumption. A great example is transportation. Twice a day during rush hour, we have a certain capacity, and that capacity gets exceeded by the consumption. And that's why we're stuck in traffic. I like Vietnam because Vietnam is a little bit different, because that rate of production, actually, that capacity changes during the day, because you have all those motorcycles that just drive on the road during the day, and during rush hour, they also go on the sidewalks. So it's always fun or confusing or cumbersome to try to walk around in Hanoi or in many cities in Vietnam during the rush hour, because all of a sudden the sidewalks get attacked by motorcycles. At least that's my experience when I was in Hanoi during my sabbatical. See, these are three. So again, I like to think about them: sustainable, tolerable, unsustainable. Where are we now, at least from a conceptual perspective, when it comes to infrastructure? The only one other thing I want to say is, we should be aware of low energy, low carbon solutions. Low energy does not mean necessarily more sustainable. Not necessarily. Sometimes yes, sometimes no, because low energy might still means that we're going to consume more, and if the consumption grows, and at some point the production might still be lower than the consumption. So that's why purely just instead of just going for low energy systems or low carbon systems, I like to think a bit differently and really think more into concepts of consumption and production. Next, we can think about resilience. Here's a very common definition of resilience from the National Infrastructure Advisory Council in the US, and is the effectiveness of a resilient infrastructure or enterprise depends upon its ability to anticipate, absorb, adapt to, and or rapidly recover from a potentially disruptive event. I actually don't like that definition at all. One of the ways that it's normally illustrated, it's with this graph here, where we have time and the state, with some kind of an equilibrium at some point, and then there's a disruptive event. So there's a sudden drop in the state, and then depending on how fast we recover, whether it's a partial recovery, full recovery, or even if we can adapt and enhance the system, then that's how we measure resilience. I don't like this because I think it applies great. It's great at some parts, at small parts of systems. When you think about the entire system, it's a bit more complicated than that. In the 1980s, Charles Perrow wrote a book called Normal Accidents, and it defines a system being composed of multiple subsystems that are composed of multiple units that are composed of multiple parts. And we've spent a lot of time looking at the resilience at the unit and part level. So a part could be a valve, for example, in water distribution systems. A unit could be a pump, and a subsystem could be the entire pumping station. And then the system is the whole water distribution systems. So what we're going to do with units and parts, and we're going to try to build redundancy, we're going to try to be robust, and it's working okay. But at the subsystem or especially system level, now we're running into a problem, because we can't be redundant in the system. I mean, if you have a water distribution system, you're not going to have a separate parallel water distribution system in case something happens to the first one. So that mentality needs to change when we think at the system level. So redundancy is just not enough. The other thing is that what we saw, the graph before really showed us that there was some kind of an equilibrium, but infrastructure systems are built over decades, centuries. So there's no equilibrium. We're not in a stationary state. Infrastructure systems are non-stationary. There's no equilibrium. So that mentality of trying to maintain certain operation really doesn't work in the longer term. So again, that's why I don't like it. And so when we scrap that notion of being stationary, then we think more about flexible, we think more about adapting. And I think it really gives us another idea of being resilient. The other thing is that we should really change our design practice from fail-safe to safe to fail. So fail-safe means that we're just going to do everything we can so that if something happens to a system, it's not going to fail. If the disruption, we're going to have redundancies, et cetera, so it doesn't fail. Now we're going to try to change it by saying, you know what, there are unknowns and knowns. That system could fail. There are some scenarios where, despite all the redundancy that we can build in, it could fail. And so what we want is, if it fails, we wanted that it fails in a safe manner. So again, different mentality. And the last one I want to mention is a different perspective again, is that we've spent a lot of time focusing on infrastructure, and what we realize now that we should really make infrastructure more flexible. So flexible is the key word, hard to operationalize, but what we want is to make it flexible. And we haven't really thought about the organizations that manage that infrastructure. But now we realize that those organizations are also rigid. They have rigid structures. And so whenever there's a disruption, or if we need to adapt, even if we're 5 years or 10 years, because they're so rigid, it's not working too well. We can't come up with nice solutions so that infrastructure is more resilient, again, just because of those organizations. So there's the term, I'm borrowing terms now from Mike Chester at Arizona State University, is agile. So those organizations need to be more agile, so they adapt, so they change as the needs of the infrastructure change. So flexibility and agility in organizations. The other thing I want to mention is really also now we realize that for the longest time, I think we tried to optimize the system so it could be more resilient. So if there's something, we're optimizing everything. And now we really realize that optimizations does not lead to more resilience, it leads to more vulnerability. Whenever you optimize a system, you can't include every single variable possible. So a lot of times what you're doing is you're actually building vulnerabilities, you're building bottlenecks, you're building places that are not as safe, where you don't have as many resources. And so optimizing is really, really, really more rigid versus another term that's called satisficing. Satisficing is a portmanteau term between satisfy and suffice. It was created in 1960s or 50s from Herbert Simon, one of the fathers of complexity science. And satisficing is different. So optimization is rigid, satisficing is more flexible. Satisficing is more about meeting a few criteria, a few thresholds. Satisficing is more even the way humans think. So for example, let's say that you want to buy a new laptop. You might want to optimize your card and your this and your that and your size and your screen, so that you have everything optimized for what you do. But then you should realize that what you do actually evolves, plus the offer that you get when you go to a computer store, you don't have the perfect computer for you. For sure, you could build your own, but again, something might change. So what you want instead is what we do instead is to think with a few criteria. I want to make sure that I have at least that much hard drive, that much, a processor that at least has that speed, et cetera, et cetera. And if we have that, we're okay. It's not perfect, but we're okay. But when we do that, because we're okay, we're actually building, we're putting flexibility in our system. And that's one of the mentalities that we're also trying to change when we think about design in infrastructure. So let's look at a case study. A great case study I like is water distribution systems. Here's the way it works in most high-income countries, at least in the US, that's how it works. We're trying to collect water, surface water, groundwater, whatever we can get. We collect that water, we treat that water, and then we distribute that treated water, that clean water, in thousands of kilometers of pipes, always at a high pressure, always at a high pressure, to make sure that no water leaks in the system from the ground. And that when we have leaks, because we always have leaks, that it leaks out. Plus, when it gets to your building, this pressure, so it just goes up to the upper stories by itself, at least for a 4-story, 5-story building, so about a 30-meter head. That's usually what we go for. So this is not a sustainable or resilient system when you think about it. That high pressure that's always there just really consumes a lot of energy, and all those pipes at some point they age and they break. And so you have big breaks, you have to dispatch emergency crews, you have to change that pipe rapidly. So I really see those water distribution systems as ticking time bombs. And I was amazed when I was in Hanoi, because I thought that the water distribution system there was vastly superior than what we have in most high-income countries. So I don't think Ho Chi Minh City is exactly the same, but it is the case in many countries, middle-income countries. It's pretty incredible the way it works. So in Hanoi, what happened is that you had a water distribution system that could not provide for the entire city. So they would provide water to one district, and then another one, and then another one, and then every few hours or every few days. And so, but houses needed water all the time. So what they did is they all put a water tank in their basement. And that water tank is in the basement on purpose, so that water coming from the road is at a higher level than the basement tank. And so you always have water flowing in, even if the pressure, even if there's very little pressure in the system. So that basement tank is there, and then when the water is there, then what you do is you pump it up to the roof to a water tank on the roof. And then when it's there, it's sitting there, it's a smaller tank, but it's there and just pumping water there whenever it needs to. The nice thing there is if you have a power outage for some reason, because it's at a higher elevation, you still have water all throughout your house. And then what you do is at the tap, if you want clean water, we have, the water might be in those tanks for some days, some pathogens might have been introduced, maybe that there's a lower pressure in the system. In Hanoi, I think we're at about 10-meter pressure in the system. It can be lower really because everyone has a basement tank. So the minimum is not so much what we need for the buildings, but it's the fire safety minimum. So what we have here is, so lower pressure goes to the basement tank, rooftop tank, then at the tap, we have a filtration system so that the water that comes out can still be, is still potable. So I think it's vastly superior. I think it's more resilient, it's more complicated, but it's more resilient because a house can be separated from the main system for several days, still be autonomous, still be fine. So I think it's much more resilient. And it's also more sustainable in part because it's lower energy. We just don't need as much energy to distribute all the water. And it's also more sustainable over time because over time we need less energy, and over time we have all those separated modular buildings essentially. So it's just a fantastic model. I'm a big fan of this model. So that's all I wanted to say. Conclusion: sustainability, resilience. We still don't have a definition. I don't think we should seek a definition, but we should challenge a little bit the status quo, what we think about it. So sustainability for me is really about being able to pursue an activity forever. Resilience is more than just redundancy or robustness. It's really about being flexible, both the physical infrastructure and the organization managing it. And that the future really lies of infrastructure. The future of sustainability, resilient infrastructure really lies in creative solutions, such as the one that we saw in Hanoi. So thank you very, very much for your time. I really hope that we're going to meet in person in the future. And I wish you a great rest of the workshop. Thank you very much.